Shweta. My roll number is 426.
Hi, this is Diksha. My roll number is 407.
Hi everyone, I'm Pratyusha, roll number 414.
Hi, my name is Supraja. My roll number is 4F0.
Hi all, we batch of A3 presenting our project face mask detection using modified YOLO. Our internal guide is Ms. Sri Padma Ma'am, Assistant Professor, Department of EC. As we know that COVID-19 is a deadly virus spreads from human to human through droplets and airborne. So, regular hand washing, wearing a face mask and maintaining social distance can prevent spread of this virus. Hence, we came up with an idea of face mask detection using modified YOLO algorithm to get rid of manual tracing of wearing a mask and to prevent further transmission of COVID-19 virus. The main objectives of this project is to design a robust and real-time mask detection system. The modified YOLO algorithm is used to detect whether a person is wearing a mask or not, and this modified YOLO algorithm is designed in such a way that its layers are reduced when compared to the existing YOLO V2 algorithm, and its performance is compared with YOLO V2 like accuracy and detection time. The algorithm of modified YOLO consisting of these steps. First step is capture the image through live video streaming, then resizing the image, ground truth labeling, designing the modified YOLO network layers, training the modified YOLO network, testing the network, and deploying the modified YOLO network to determine whether a person is wearing a mask or not. In face mask detection using modified YOLO is designed and implemented using MATLAB tool, where we have written the code in the live editor, and the first step is pre-processing datasets. So the first step is image resizing. The images are downloaded from the Kaggle website, which are of high resolution with more than 1063 x 1063 x 3 and with uneven sizes. So these images are in the dataset images folder are resized to 416 x 416 x 3 to account for modified YOLO architecture. Then these images from the dataset images folder are splitted randomly to train resize folder and test resize folder. Here the dataset images folder consists of 816 images, which are splitted randomly to 408 images in train resize folder and 408 images into test resize folder. The images in the train resize folder is used in ground truth labeling further, and the images in test resize folder is used in last phase to know how network performs with unseen images. Then creating ground truth. So here in ground truth labeling, the objects of interest are labeled in a stream of images. In face mask detection system, a face mask is labeled in an image using ground truth labeling, and the location of mask in an image is saved. Then this label data is imported into workspace has a gtruth variable, and this gtruth variable is converted into training data set here in the step 4. And in stage 2, that is training the modified YOLO network, the first step is designing the modified YOLO network layers. As I've said previously that the modified YOLO network has reduced layers when compared to YOLO V2 network. So as I referred that the YOLO V2 network has 150 layers, whereas modified YOLO has only 37 layers. The 37 layers. The modified YOLO model runs a deep learning CNN on an input image to produce network predictions. The object detected decodes predictions and generates bounding boxes. A modified YOLO model is designed layer by layer, and the model starts with input layer. Then the detection subnetwork consists of series of convolutional, batch normalization, ReLU, and max pooling layers, followed by fully connected layers as YOLO V2 transform layer and YOLO V2 output layer. So coming to the first layer, that is input layer. The input layer inputs images to the network and apply data normalization. The input layer is in an image of size 416 x 416 x 3. Then we have given a filter size of 3 x 3, which is used in convolutional layer. Then coming to the middle layers consist of convolutional, batch normalization, ReLU, and max pooling layers. Convolutional layer convolves the input by moving the filters along the input vertically and horizontally and computing the dot product of the weight and the input, then adding a bias term repeating the same computation for each region. Then coming to the batch normalization layer, A batch normalization layer normalizes a mini batch of data across all observations of each channel independently. To speed up the training of the convolutional neural network and to reduce the sensitivity of network initializations, we use batch normalization layer between convolutional layer and ReLU layer. Then coming to the ReLU layer. ReLU layer is nothing but rectified linear unit layer which performs threshold operation to each element of the input, where any value less than 0 is set to 0 and any value greater than 0 is taken as a output. Here we have set a threshold of 0.5, so any value less than 0.5 is discarded and any value greater than 0.5 is taken as an output to the next layer. Then coming to the max pooling layer. Max pooling layer performs downsampling by dividing input in rectangular pooling regions and computing the maximum of each region. This value is given to the given as an output to the next convolutional layer. So as you can see here, there are 7 convolutional layers, 7 batches of convolutional layers, and each batch consists of similar pattern of convolutional, batch normalization, and ReLU and max pooling layers. So as you can see, this corresponds to one batch. This corresponds to one batch. Here similarly 7 batches of convolutional, batch normalization, ReLU and max pooling layers are present. Then creating L-graph for the modified YOLO network. Then here in the step 2 we combine the initial, that is the input layer, and the middle layers and convert into L-graph object in order to manipulate the layers. So then here computing the number of classes based on input data. Has here number of classes corresponds to the number of objects that need to be predict in the network. So as you can see that only mask is the only object that need to be predict. So num class is equals to 1. Then defining anchor boxes. Anchor boxes is a set of predefined bonding boxes of certain height and width. These boxes are defined to capture scale and aspect ratio of specific object classes you want to detect and are typically chosen based on object sizes in your training datasets. So as I said that I have done this code previously. So these are the anchor boxes that I have got, and that is 72, 89, 219, 380, 43, 57, 142, 142, 187, 92 and 117. Then assembling the modified YOLO. So YOLO V2 layers creates a YOLO V2 network which represents the network architecture of YOLO V2 object detector. ReLU 7 is a feature extraction layer, that is last layer in the middle layer. These features, the feature extract from this layer are given to the input to the YOLO V2 object detector subnetwork. You can specify any network layer except fully connected layers as feature layer. So L-graph is visualized using network analyzer app. So I have run this code and have got this L-graph from the network analyzer app. So it starts with the input layer and the batches of convolutional, batch normalization, ReLU and max pooling, and followed by other like 7 batches of layers are given. Here we have given input of images 416 cross 416 cross 3, then the convolutional layer which has filter size 3 cross 3, and there are 16 filters of 3 cross 3 filter with a stride 1 1 and padding 1 1 1 1. These stride and padding are default values. Then batch normalization, ReLU and max pooling consists of similar stride 2 cross 2 and padding of 0 0 0 0. So this after the middle layers we have YOLO V2 layers, that is YOLO V2 convolutional, YOLO V2 batch normalization, YOLO V2 ReLU, and then followed by transform and layer and output layer. So here YOLO V2 transform layer extracts activations of last convolution layer and transforms the bonding box predictions to fall within the bounds of ground truth. So in output layer, the output layer provides defined bonding box locations of target objects, that is mask. It defines some anchor box parameters and implements a loss function used to train the detector. So here modified YOLO layer have said that there are 37 layers, which includes 1 input layer, 7 convolutional layers, 7 batch normalization, 7 ReLU layers and 6 max pooling layers, along with YOLO V2's convolutions, batch normalization, ReLU, and then transform and output layer. And coming back to the code, in the step 5 we have trained the YOLO V2 network. So here has set training to false because here training takes around 3 to 4 hours to train the network. So I have trained previously, and the results are and it is stored as a MATLAB data. So here we have set options has initial learning rate as 0.001, because the learning rate defines the rate at which the network learns from the data, and mini patch size as 16, that is the data is divided into mini patches of 16, and then max epoch refers to the rate at which the total refers to how many times the total data is trained, that is full pass of the data. Here max epoch is set to 80, and verbose frequency is set to 50, that is rate at which the output is printed in the command window here. So then we can change these parameters like initial learning rate, mini batch size, and max epoch. And we have done that. We have changed these parameters, and we have trained with multiple times to know how the network performs and how the accuracy and detection time is varying based on that. And we have concluded that and we came to know that with epoch 80 and mini batch size 16 and initial learning rate has 0.001 has better performance, that is better performance in terms of accuracy and detection time when compared to the other training options. So then this training data set, that is which consists of ground truth label data, the L graph which consists of the layers, the L graph consists of layers, that is input layer, middle layers, and then options, which are these options, training options, which are given to the trained YOLO V2 object detector, which trains the network, and this is stored in the form of detector modified YOLO object, the variable, and this whole data is saved in the form of mask modified YOLO mat file MATLAB data. And then this MATLAB data is used for testing the algorithm using still image. So first of all, we have imported this mask modified underscore YOLO.mat, which is the data file, and we have loaded that, and then we have taken an image. So here I have taken various images like from the various images from train and tested resized folders. So from train resized folders I have taken an image, then I have resized to 416 cross 416 because it supports YOLO architecture, it suits YOLO architecture. Then its B box refers to the bounding box locations, and the score that refers to the accuracy, and the label means the mask one. So here we detect object consists of detect modified underscore YOLO, which is the object we got while training, and we have set and the image is given as an input, and threshold layer on 0.6. So when we have run this code, we got we have tested for still images. So these are the outputs. This figure is taken from the train resized folders, and it has an accuracy around 0.797. Then this is an image which is similarly taken from train resized folder, which is able to detect 2 persons mask, and the first person has an accuracy around 0.93 and second person has an accuracy around 0.86. And the next image is taken from the test resized folder, which has an accuracy around 0.97, and another image is taken from the same train test resized folder which consists of 2 persons, and it's perfectly able to detect mask of 2 persons with an accuracy around 0.89 and 0.64. And it also displays an output that grade P safe if the person is properly wearing a mask along with its accuracy, and if a person doesn't wear a mask, it shows please wear a mask.
Stage 4 is about deploying the algorithm using the live webcam. So in this stage, we'll be checking whether a person is wearing mask or not using a live webcam. So for this process, we need to integrate a live webcam in our laptop. So we'll be going through each and every step. So step 1 is about parameter setting for the execution. So for the execution of this, we need to set the parameters of the webcam, such as its brightness and its resolution. And frames per second is taken as an 0. And step 2 is about choosing the trained model. So here we need to choose the model which has been trained before. So modified underscore YOLO is been chosen. And step 3 is about running live webcam for the mask detection. So here the live webcam will be on, and it will be checking lively whether a person is wearing a mask or not. And if a person is wearing a mask, then the output on the screen will be like grade B safe, and if a person is not wearing mask, then the output will be given as wear the mask. So output of it, since I am wearing mask, it is showing as grade B safe on the screen, and frames per second is 3.63 and it is increasing. As the frames per second increases, the detection time decreases. Therefore, the image captured through the live video stream will be at a faster rate, and here the accuracy is 0.90 and it will be changing depending upon the facial position of the mask. If I move a little bit at right, the accuracy will be changing, and if I move a little bit at left, the accuracy is still being changed. And once if I remove the mask, it will be showing as wear the mask on the screen.